All right, so in this video, we're going to get information from the graph of a function, okay? So you can see the function g here graphed out in red. We can refer to this as a graph or a curve, whatever you want to do. So what we're going to do is we want to analyze the graph. We want to be able to determine specific values for f of x, okay? We wanted to be able to determine domain and range. We want to be able to determine x and y intercepts, and so on, okay? So there's a lot of things you can pull from the graph of a function, which this is. And this function is named g. That's what the g is there for. It gives us the name of the function, okay? So first thing I want to do, we're going to estimate for different values of g of x. We can say f of x or g of x. Remember, those letters are interchangeable, not a huge deal. So g of -2. So what that means is we're looking for the y-coordinate, basically, or the height of this graph above or below the x-axis at the x-coordinate of -2, okay? So first thing we want to do is we want to put an ordered pair there. We want to put a point there, and it's going to make it a little bit easier for us. So at this location, the y value, the y-coordinate, is going to be 4. And what this means, g of -2, means what is that value when x is -2. Now you can see the origin is here. So we're -2, we're 2 units left of the origin. So what we want to determine is what is the height of the function at that x value, -2. So we can count that. That's 1, 2, 3, 4. So g of -2 has a value of 4. Okay? So next thing we want to do is we want to figure out what g of 1 is. So we want to go over here to 1, and we want to see where that graph is with an x value of 1. So I put a point there for you. So what we can do is we can determine the height, in this case above the x-axis. So 1, 2, 3, 4, 5, 6 units up. So we would say g of 1 then is going to equal to 6. All right? So try g of 4 on your own, and then check your work. Okay, so g of 4, we're going to go right here to 4. We're going to go up. It looks like we're a little bit above the grid line there. Okay, so it's not going to be exactly 2. And our directions say round to the nearest 10th. And because these grid lines are pretty close together, I went ahead and called that approximately 2.1. If you called that 2.0, I wouldn't have an issue with that. But just notice it is slightly above the grid line there. So we want to go a little higher than 2. All right, so that's how you determine values, the height of the curve, okay, for different values of x, okay? Now, domain, remember, we've talked about domain many times. Domain is the values of x, okay? How far to the left does the graph go? How far to the right does the graph go? Now, it's important to note here there aren't arrows that tell you this graph is continuously moving down into the left here and up into the right here. So this graph is confined to what you see here in red. Okay, that's important to note. So for the domain, our smallest value, x value, that's present here is -2. Okay, and there's no open dot there. It's a closed dot, so we consider that to be part of the domain. The largest x value that's present is over here at +8. So this was 4, 5, 6, 7, and 8. So my domain then would be the interval from -2 to +8 inclusive, meaning -2 and 8 are both part of the domain. That's why we use the brackets. If you prefer writing that in the inequality notation that we use sometimes, you could also say x is between -2 and 8 inclusive, using the inequality symbols this way. All right. Range, remember, is the y values, the dependent variable here. So how low does the graph go? Okay, looks like the lowest spot is right here at +2. And the highest point this graph reaches is right here. Okay, we're going to have names for these pretty soon. So the highest value this graph reaches is here at +7. So my range then is going to be the interval from 2 to 7, inclusive, okay? It looks like this might dip a little bit below the grid line there, but I can't tell that for sure. So we're going to leave that at 2. This definitely touches 7 here. So that would be our range, including those values 2 and 7. In the inequality notation, notice here we're using y because range is the y value. You could also put g of x here if you want to, would be between 2 and 7 inclusive. All right. Now, intercepts. This one's pretty easy because there's only one intercept. Notice the x-axis is here, and the graph never touches the x-axis, so there are no x-intercepts. There is one y-intercept, though. The y-axis is here, so if you'll notice, the graph touches the y-axis, crosses the y-axis right here, okay? So I've got my y-intercept at 0, 7. Okay, so that problem was a little easier than might normally be. You can have as many x-intercepts as a function, like you can have infinite x-intercepts for a function. You can only have one y-intercept, but we were lucky here. There are no x-intercepts to speak of. All right, now find the values of x for which g of x equals 4. So if g of x equals 4, what we want to do is we want to graph that horizontal line at where g of x is 4, or where y is 4. Remember, g of x and y are interchangeable. So if g of x equals 4, then y equals 4. And that's going to be the horizontal line there where y is 4, okay? So for it to be equal to 4, it means we have to be on that line. So I've already covered this point here. It was g of -2. So the first x value is going to be at -2, okay? The next place is going to be right here. Let's go ahead and put a point there. So the x value here is going to be +2. So that's going to be my second answer. And then there's actually a third place where g of x is equal to 4. Let's put a point there, and that's going to be at 4, 5, 6, 7. So the third x value would be +7. Okay, so notice that at each of these three x values, -2, +2, and 7, they're on that horizontal line through y equals 4. All right? Now then, this next question is a little bit more complicated. Find the values of x for which g of x is greater than 4. Okay, so what that means is if this is where y or g of x is equal to 4, for it to be greater than 4, we're going to be above this line, okay? So we've got two intervals here where that's going to be the case. We've got this interval, we've got it above the line y equals 4. Okay, there's going to be two intervals where that's the case. So the first interval you can see is going to be from this point to this point. So notice everywhere on this interval, except for the points, because that's actually, x equals 4 there, we're above that horizontal line. Okay, so on this interval, from -2 to +2, we're greater than 4, okay? So that's going to be my first answer. Notice I've got parentheses in my interval because at -2 and at +2, the graph is actually equal to 4. The function is equal to 4, all right? There's one more little interval here where the function is above that horizontal line y equals 4, all right? So it's from, this is 4, 5, 6, 7, so it's from 7 here to 8, okay? Includes 8, doesn't include 7, okay? So we should have brackets here, all right, not parentheses. So it includes 8, but remember, that's where the domain ends. So it includes 8, but it does not include 7, okay? So looking at what we've done here, we're able to pull all kinds of information, different values for g of x in this case, the domain, very easy to find here, the range, very easy to find here. Intercepts, we were lucky there was only one. And then we want to be able to use that understanding of where g of x equals 4, there's going to be a horizontal line there, and that's going to be everything we need to help answer any questions. Now, if I said where is g of x less than 4, then it would be this interval from +2 to +7. Okay, but that wasn't a question here. All right, so that's how you can pull information from the graph of a function. There's so much you can get from a graph, and we're going to be building on that as we continue through the class.